What's up guys, Max here and welcome back to my temporary dungeon. So, today I'm going to talk about a cool topic. Yes, cool because I'm talking about thermoelectric cooling. So, something like this. This is called TEC or Peltier cells that use the Peltier effects to move the heat from one side to another using electricity. And there's a hot side and the cool side. The hot side gets really hot and the cool side gets really cool. And we can have a delta temperature without any loads for around 40 degrees of delta. So if I can cool enough the heat side to 40 degrees, I have zero on the cool side without any load at it. Now I'm going to use it for cool a CPU. But it's something that I'm not a big fan for daily use. I use it for extreme overclocking for the chipset, for other specific application, but for CPU is not that efficient since we are moving a lot of current. This is a big one and it's 30 amps. I'm using one of 15 amps, so at 15 volts I'm pulling around 225 watts. So you have to add 225 watts to get some gain in temperature with your system. That is a bit crazy and terribly inefficient. But let's get to it and let me show you in real use how is it. Alright, so let's talk about this system. I'm using an X470 motherboard with a Ryzen 7 3700X, so a low TDP CPU, 8 core but low TDP. That should be easy enough for the task that I'm trying to do. Well, a kit of ballistic, unusual system. So, the main part of this setup is the cooling, because as I told you before, this system on the hot side gets really hot, and you need something that is powerful enough to keep it cool. Otherwise, everything just produces more heat and you tend to overheat the system like more than 100 degrees and you risk everything. So, this is a downside. But for this test, I'm using the, I don't know if you can see it, the EVGA CLC 240. This is a very nice, and honestly after this test I'm surprised that I had a lot of power to cool this solution, since when I used Peltier back in the days, I talk about 2002, 2003, so like 20 years ago, I had to use big radiator from a car or even a bucket full of ice to cool the Peltier that I was using. So this is very nice. I didn't expect that. So, okay, this is the system. So we have a Ryzen CPU that should be not so much power hungry in terms of dissipation, a good AIO, and of course the Peltier system. I'm using a Peltier similar like this. This is 10 amps, I'm using a 15 amps, so 225 watts. So to make it works, it's not easy, because many tried, the Bauer tried to make a chiller with the Peltier, cooling the Peltier, and the Peltier cooling the water into the loop and into the CPU. But that is terribly inefficient, since you have to one step more than what I'm going to do now, and you lose efficiency. What I'm doing is the CPU, a pure copper buffer. The buffer is very important because the Peltier cell is very sensitive to peak temperature. So I have to put a big buffer, a pure copper buffer plate is like 1.5 centimeters. It's like this between the CPU and the cold side. Then the cold side, the TEC, of course, another buffer, since it's very important that the upper buffer needs to cover all the Peltier. Otherwise, even if you leave a corner outside, the whole system doesn't work. So I need another buffer and then the AIO. So it's like a sandwich. If I can, I'll show you later some photo, or I can try to tear it down. But you have to keep a buffer to make the temperature not peaking, because the peak just ruin the balance and you end up having weird temperature or the Peltier not working at all. So this is the base system. Now, as you can see, I'm running 15 volts with 15 amps, so 225 watts. And I got at idle 40 degrees on the hot side and 9.6, 9.8 degrees on the cool side. It means that they have a delta of 30 degrees. So we are losing 10 degrees of the rated delta, that is 40. So only applying a very small load, because this Ryzen at idle is very power efficient, and we have lost 10 degrees of delta. If I don't apply any loads at all, and I'm able to cool the hot side to 40 degrees, I have 0. And if I can apply like 30 degrees, I have like -7, something like this. So at idle, we have 10 degrees on the cold side and 40 degrees stable on the hot side. And this is running for about 1 hour, so it's pretty stable. But now let me show you with the system running how the thing is working. So we have now temperature around 10 degrees when it's not spiking. Another thing to keep in mind doing this thing with Ryzen is that the die is 7 nanometers and it's very small. And having a small die, it doesn't really transfer all the heat when it's peaking to the AHS, so to the buffer and then to the cold plate. The problem with that is that we don't have a uniform heat transfer, let's say a fast heat transfer from the die, the small die, to the buffer. And we are going to see some spikes up and down, but as you can see here, sometimes you have 7 degrees, 9 degrees, so it's pretty cold. But keeping a system at idle is pretty easy. The problem is when we heat the CPU and we have to transfer all the heat from the CPU going through the Peltier cells and then through our cooler. And well, now you're going to see what happens. Okay, so now we have a baseline that we are 6, 7, 8 at idle. It's pretty nice temperature. So we have a cold side around 10 degrees that the probe can be a bit different from what the CPU really is, so there's a tolerance, but anyway, we are pretty low on temperature at idle. Everything is in check since the cooler is powerful enough to maintain 40 degrees on the hot side. We are still at 15 volts. I can turn it off now, so I start beeping all the way, but anyway, the Peltier is at full power. And now I'm trying to run Blender, so a very heavy test, but that is a real case scenario. If anybody have the idea to use Peltier to cool down the workstation or their PC during big loads, thinking that they can overclock it or they keep the temperature lower. Anyway, let's see what happens. Okay, take a look at the temperature, mostly the delta, that is very important. Then I will explain you later an important fact about Peltiers. So now the temperature is rising. Now we have 38 degrees on the CPU, so we went from 6, 8, 10 degrees from 40 in 3 seconds. So now the heat is going from the CPU die to the AHS, to the buffer, to the cold side. Now we are at 20 degrees and still 40. So the delta is getting smaller. And the CPU temperature after 30-40 seconds, we are at 50 degrees. So not much different from a normal cooler. So now you will see that the CPU will start heating, and the delta, we have now only 10 degrees of delta, 12. So we are reducing that delta, and it's kind of dangerous because after at some point that I friendly called event horizon, when you go too hot on the cold side, the Peltier system doesn't work at all, and you end up like nuclear. Everything starts to heat up, and you can reach like 100 degrees in seconds. And it's very dangerous since you can break stuff. Now, as you can see, we are at 60 degrees. After, this is a benchmark that is like 3 minutes and something. So we are like 1.5 minutes. And we are still at 63 degrees. Probably with only the I/O, I will hit 80 degrees, maybe, but 10-15 degrees in exchange for 225 watts of power plus all the TDP, all the power that the AEO have to put outside, so in your room, I think it's not worth it at all. Since now we are 70 degrees and the temperature is rising, now we have a delta of 4 degrees and we may start having problem now. So we have a low TDP, since if you see here in the Ryzen Master, the TDP is around 70 watts or something. So we are not using a big CPU that someone can say, no, the CPU is too big for this system. This is a tiny CPU in comparison. It's rated 65 watts. And if you do rendering or if you need some power to overclock, probably all the cost and effort, it's probably better to buy a better CPU directly, like the 5950X. Anyway, we are about to finish our test here. We are at 72 degrees and we have now 2 degrees of delta. But as I told you, it's dangerous and useless, since we are using a lot of power, we may have a lot of issue without any real benefit. Now we are 3 minutes and 12 seconds. So very similar to what it will be with a standard cooling solution. And now if you check the temperature is going down, down, down again to reach after it stabilized, equalized around 10 degrees or like it were before. So it doesn't take long to get to idle again, but as you've seen, it's useless. And now I can say, okay, I will try with this one, the big one, that is twice as power as the one that I'm using. Unfortunately, I don't have a plate big enough to cover the hot side and the cold side. I ordered through Amazon probably in a couple of days and I will repeat the test. But now we are talking about around 500 watts. So it's like having 2 systems more to do the same thing. Again, this is for fun, for science, and especially because I'm waiting the Ryzen that is coming tomorrow, the new Zen3, and I had to kill time. So it's just, wasting time around something that I already knew that was inefficient. So I just made this video, since I used the video of Linus Tech Tip that he was showing the secret EK water block that we all think that is a Peltier, a tech cell, and well, probably they did something different. They're a good brand, maybe they make the system work with a controller, I don't know. But so far, as I can tell you, it's pretty useless. Useless, inefficient, dangerous. We are at 15 degrees and we have like 24, 25 or 28 here. When you go below, it's like when you have a cold beer in your hands. You know, the water that start dripping, the same effect is actually happening now. So in my cold plate, the buffer, and around the CPU, I have like water drops. It's dangerous, since if the water goes into the motherboard, maybe you have some short circuit, you can damage the lines of the motherboard in the long term. That, well, back in my day when I used a system like this for daily, when I had a Core 2 Duo, so a very small CPU. But anyway, with some neoprene, you can fix the issue of insulation and water, so you can fix that issue. But still, you have to use a lot of power and you hit your room badly, since you have like 225 watts only for the Peltier, plus the system, plus a GPU. You end up like having 800 watts of thermal that goes into your room. Maybe in winter is nice, but in summer I don't know if it's a good thing to do. Anyway, we can do a last thing and then I stop doing this crazy madness. Something that we can do is trying to manually overclock the CPU using a low voltage, because if I can make the CPU efficient and stay with a good clock with low voltage, we have less heat to transfer. So usually if you manage to tweak the system in a way that is very power efficient, so the cold plate doesn't really have much work to do, and if you can stay at around 20 to 30 degrees, you have a gain of 100 or 200 megahertz, depending on the luck of the CPU. So this is something that I tried before and I wasn't successful, but we will try it again, just for the sake to try and see what happens if you do a manual tick over this system. Now I have to say that this CPU is not a good overclocker, so you can find better, but this result doesn't change much. So we are now back at 7-8 degrees as baseline. I have set a manual overclocking around 1.123 volts and 4.1 gigahertz, and I'm running the same test. So we are probably having an average of 100 megahertz more using less volts, so I will produce less power to dissipate, and I'm using less power from the grid. Well, at the end is not that much, but we have an, let's say for the CPU side, a more efficient system. Then, let alone that I will draw 225 watts for the Peltier alone, but that is a bit stupid, you know. You seek efficiency for the CPU and then you're just wasting 225 watts just to power the Peltier. So anyway, now I'm running the test. We have 40 degrees, and here we have 20 watts on the cool side, raising, and still 40-41 degrees on the hot side. And as you can see, the coolant temperature is 38 degrees, so the AO is just doing fine, perfectly fine. Honestly, as I told you before, I'm impressed because cooling a Peltier is not easy, and the water block needs a specific configuration, because usually back in the day we use a Ibris T-Rex 3 that was a water block designed specifically made for the Peltier cell, that inside there's a lot of things very high innate, and it was specifically designed with a flow that was able to dissipate a lot of heat from the water block that was cooling the TEC. And this design is different because it's designed to cool a CPU and not a buffer block connected to a Peltier cell. But anyway, this is a good cooler. And as you can see here, lowering too much the voltage, I have an error. It means that my system isn't stable. But you know, using 4.1 gigahertz and 225 watts, and I can even run a CPU at 4.1 gigahertz, and the default is at 4 gigahertz, so even 100 megahertz is a bit ridiculous. All this effort, all this risk, all the energy to not be able to overclock properly a CPU. So I can try to raise a bit the voltage, 1.2 here, that should be okay, 1.177. We do the same test. Okay, so now at least I expect that we can finish this test at 4.1. But again, if I can finish the test at 4.1, it's 100 megahertz. Again, all the effort for 100 megahertz, not worth it, since I don't know what a commercial solution may cost, but if you count that you need a good radiator, a good power supply, because now I'm using an external power supply. Okay, you can buy it in Amazon for like €20, $20, it's fine, but you know, having a case with a lot of cables is kind of bad. Anyway, so we are now at 4.1 gigahertz, 52 degrees on the CPU, 30 degrees on the cold side, 41, 42 on the heat side. Again, the delta is shrinking. The full load temp is rising, 57, is going up again. And honestly, again, I don't see that is a viable solution, because if I have to use the Monster TEC and using 500 watts, 500 watts is a lot. Plus the TDP, I think the thermal TDP is even higher. And with 500 watts, I can power a phase change cooler, and I get the system to -40, -50 for the same amount of energy, because the phase change use is like the air conditioner, is much efficient. Usually the Peltier cells are used when you have a small load to cool, like well, components, radio components or something like that, and you need like passive cooling or air cooling, and you don't have space to put a big air conditioning to do the job. But for CPU is not efficient because the CPU is very power hungry, and overclocking we have like 200 watts of thermal TDP to dissipate, so it's very inefficient. Now we are 40 degrees, CPU at 68. Okay, I'm running on 4.1 gigahertz. But now if we can finish the benchmark, we will see that the other one was like 3 point something. We are not going to do the benchmark in 1 minute less. So we are doing again a lot of effort to gain what, 3 seconds over 3 minutes. It is nothing. If you do it for an hour, yes, maybe you gain like 10 seconds, 30 seconds, but 1 hour of 300 watts more, completely useless. Okay, now again we're almost to finish the benchmark. We have 42, 43 on the cold side, on the supposedly cold side, and 45 on the hot side. 2 degrees of delta. So 2 degrees of delta means that basically I'm wasting energy, because there's no big difference between the two. I can remember the other one, but I think we are similar or a bit better, but we're talking about a couple of seconds over 3 minutes, so nothing. Using a lot of power for nothing is simply stupid. Anyway, so this is what the test goes. When I receive the bigger plate, I'm going to use the Monster TEC just to see if we can tame a relatively small CPU. But again, if I'm having issue cooling a 64 watts TDP using a TEC of 15 amps, so 225 watts, so we're talking about 3 times more, what about cooling like a CPU like an Intel i9 or even a Ryzen 9? Is going to be useless for the amount of power, effort, risk that I'm going to do this. Anyway, this is all for fun. I'm waiting the new Ryzen coming tomorrow. I have to waste some time tonight, and well, it's cool to have some fun sometimes, even if it's stupid. You can expect another video when I try out this one, maybe with the new Ryzens, since they are slightly better for the thermal capability, and probably with a boost that is working better than this generation, since the Zen Plus was better. With the temperature going down, you have a big boost with the PBO, but then the AMD took off the PBO, so we don't have PBO anymore for the Zen Plus, and was a mess to test. So hopefully we can see how is working this system with the new Zen3, and hopefully they have a PBO or an auto OC working, and maybe we have a benefit running this, and 10 degrees, 20 degrees may give us a big boost, an automatic boost, but we will see. So for tonight is everything. I hope you enjoy this crazy stuff. If you want to support this channel, I have a Patreon, since I'm an independent channel and everything I do is paid by myself. If you want to support, you're more than welcome. Subscribe, like the video if you like it, comment if you want to know more, join my Discord, and see you in the next one.